Welcome again to my YouTube channel. I want to say first of all, thank you guys for being part of my channel, for supporting me by clicking subscribe, like my video, comment, and as well share it with your friends. I say thank you so much for being part of my channel. Okay, as I always say, I'll be posting many interesting videos that will help us in our academic to see that we'll keep getting excellent grades, distinctions in our courses. So today I'm back with another important aspect of our courses, that is experiment on triangular prism. This is with respect to light rays. So this topic is under light waves. We want to see how to solve this difficulty people do have in exam hall because of eye issues. Some persons, while performing experiments on rectangular prisms, on triangular prisms, they find it difficult to place their pin where it's supposed to be. And because of that, they fail in getting the accurate readings or manageable readings they are to use for their experiment. So with these techniques I am to introduce in today's class, you will see that even if you have eye issue, eye problem, or you want to perform this experiment in midnight where there is total darkness, you will see that you will get your readings, you will get your results excellently. I mean 100% accurate. So this topic for today is on light waves. I repeat, light waves under refraction of light waves. Remember, there is another one we call reflection. Refraction, that is REF, and there is one we call refraction. Refraction. Please look at the one we are to discuss today. Refraction of light waves. Now, because of our time, this video will be in two parts. In the first part, we want to see how to get our readings without touching our apparatus, without touching the pen, the drawing board, whatsoever. You get your readings accurately and faster. To do that, let's recall to ourselves some important points we may have forgotten, but we know very well concerning refraction of light rays. First, we recall that refractive index of triangular prism and rectangular prism is approximately 1.5. That is no unit. Refractive index of triangular prism or rectangular prism is approximately 1.5. Have it in your mind. We also recall that between air and glass, one is denser and the other is less dense. Air is less dense, glass is denser. Now, in refraction of light rays, density of mediums are involved or are considered. So it means that light will be coming from one of the lesser density of the medium to another medium. Take for instance, see what I mean. When we talk about refraction of light rays, here is taken to be our air. Light ray is coming from the air. Okay, look at our arrow of the light ray, mean it's coming from the air going, and it meets the boundary between the air and the glass. Here is your glass. Now, air, once light ray is coming from air is noted to be less dense. Air is noted to be less dense, while glass is noted to be denser or high dense or high dense. So air is noted to be less dense medium, while glass is noted to be denser or high dense medium. Now, once light ray is coming from air, which is the less dense, and it meets the boundary between the air and the glass. Look at the boundary, you have what we call normal here. So once you get there, while it was coming from air, entering the glass, we'll say it will refract away from the normal. Refract away. It means that the angle here will be bigger. The angle here will be bigger. That angle here, we call it incident angle. I repeat, once light ray is coming from less dense medium, which is air, entering the denser medium, that light ray moving, we call it incident ray. Incident ray. Now, when it gets to the boundary between the less dense medium and denser medium, what we have is that there will be an angle formed between the light ray and the normal, and we call that angle incident angle I. Now, on entering the denser medium, which is the glass, it is noted that the light ray will be refracting. We say refracting, not reflect, but refract, from the word refract. It will be refracting toward the normal. This is the normal line. It will be refracting toward the normal. We call here R1. Then that means the angle here, the incidence angle, will be greater than the what? R1. Okay, now it will continue moving this way to meet the boundary between the glass and the air. That is the boundary between the denser medium and the less dense medium. As you meet it, it will meet it at this point. We call here R2. It will form another angle R2 here. Then, on going out of the denser medium, it will form what we call emergent angle. Emergent angle, that is the angle between the normal and the emergent ray. And this will what we call emergent ray. Emergent ray. That means the angle, emergent angle, must be greater than the R2, the refracted angle. So we need to have this in our mind, that when light ray is moving from a less dense medium to a denser medium, such as glass, it will be refracting toward the normal. It will be refracting toward the normal. But when the light ray is moving from denser medium to a less dense medium, it will be refracting away from the normal. That is, away from the normal means the angle here will be greater than this R2. While this one, I will be greater than R1. Please note this point. Now, also note that our refractive index of glass prism or triangular prism or rectangular prism is approximately 1.5. I repeat, recall that the refractive index of a triangular prism or rectangular prism is approximately 1.5. Having this in mind, now this I is here. The angle formed by triangular prism is approximately 60 degrees. This 60 degrees, we call it our A. That is, it's like an angle formed in an equilateral triangle. The value of each angle in an equilateral triangle, from the name equilateral, it means that their angles are equal. So it is approximately equal to 60. Sometimes in the experiment, you will have it to be between 59 to what? 61. Some persons can get 59 degrees, some 60, some 61. So at this point that they asked us to write the angle we got here, you can write it 59, 60, 59.00, 60.00, 61.00. Then you can also write 59.00 and 61.00. Why you choose it this way is 59 plus, remember I said it falls between 59 to 61. Some persons can get 59, some persons can get 60, some persons can get 61, depending on the triangular prism given to them. Okay, so we now say, because we don't want to touch the equipment, we write 59, 60, 61, 59, 61. That means when I add everything and divide it by 5, it will be giving me 60 degrees. We note that. Then this refractive index, which is 1.5, some persons can get 1.48 at the end of the experiment, while some persons can get 1.49, 1.50, 1.51, 1.52. So I suggest let the range you have to pick and use be between 1.48 to 1.52. So note it as we want to embark on this experiment. Then let's derive some important formulas we need in this experiment. Okay, to derive it, this is I. We will use simple laws of triangles or laws of angles to what? To derive it. If here is 60, our A, remember I called this 60 degree our A, our letter A. Someone can take any letter to replace this letter A. You can say letter K, letter B, and so on. This angle here, A, this angle A is equal to angle here. Note it, that this angle here is equal to this. Then remember that there is a law of angle that says a stereo angle of a triangle is equal to sum of two opposite interior angles. So here we will say that A is equal to R1 plus R2. Why? A stereo angle of a triangle is equal to sum of two opposite interior angle. So we have this plus this is equal to this. But before then, We noted that refractive index is equals to sine of incidence or sine of incident angle all over sine of refracted angle. Here, sine here is equal sine here all over sine R1. That means making R1 subject of formula, we will be having it to be equal to R1. We'll be having it to be equals to sine. Let me write it well. We'll be having it to be equals to R1 equals to sine inverse of bracket sine I over refractive index. We'll call this formula 1. That is, for us to get our R1, we'll use this formula. You'll get it. Then, how did we arrive at this? Look at it. Carry sine R1 up. That is cross multiply. Carry sine R1 up and the refractive index, take it down. You'll be having sine R1 equals to sine I over this. Okay? Then, making R1 subject of formula, the simple law of math tells us that to remove sine here, it means take sine inverse of the other side. You have sine I over refractive index. Please note it. I think I've explained it now. Then, another thing we have to note is, since A is equal to R1 plus R2, we will say that it means that R2 will be equal to A minus R1. And what is our R1? It means that R2 is equal to, what is our R1? A minus R1 is sine inverse of sine I all over refractive index. So with this, I will get my what? R2. With this formula, I will comfortably get my R2. Whatever I get here, I minus it from A. And I said that is equivalent to 60 degrees. So you say 60 minus whatever I get here. They will give you the value of I. Most times they will tell you that I ranges from 30, 40, 50, 60, 70, 80. So they must give you the value of I for you to what? Put it here. And I said this refractive index, it falls between 1.48 to 1.52. So you can use your this to be equal to 1.48. I don't advise students to use 1.5, the exact value. No. Pick 1.48 or you can pick 1.52. Any of these two is okay. 1.48, 1.49, 1.51 and 1.52. Don't pick 1.5 exactly. Okay? So that means once I do that, I will get my value that this is this and my I is equal to 30 degrees. My I is equal to 30 degrees. Once I plug it here, and my A is equal to 60 degrees. They are constant. Once I plug it here, I will be getting my value of R2. I'll put it here. So that means I've gotten my R1, R2, I know my A. Then we have noted formula 1. Then let's call this formula 1. Then this one will be formula 2. This one will be formula 3. And this one will be formula 4. Please, we need to note this because we will use this formula. We will use all this formula to embark on how to get our reading. We'll just use this formula and get our readings without touching the apparatus. Okay? Then from here, we remember that there is what we call vertically opposite angle are equal. From here, follow my hand. Where here is my eye, then here is R1, and here I don't know the value. Then I come this side again. That is for this. Here is my E. Here is my R2. Okay, recalling that rule that says vertically opposite angle are equal, applying it here, it means that if here is S2 and here is S1, that means E will be equal to S2 minus S2 plus R2. Because when you sum the total of this side, it is equal to the what? E. And here, I is equal to S1 plus R1. That is vertically opposite angles are equal, or opposite angles are equal. Noting that. Now, because we have noted it, what is our S1? Remember, why we are applying this rule here is because we want to get the value of S1. S1 equals to I minus R1. Then here, S2 equal to E minus R2. So, having noted this, we now package them and put it here. We now say that tells us that our angle of deviation, which is equal to S1 plus S2, angle of deviation, which is equal to S1 plus S2, is the same thing as what is our S1? We say I minus R1 plus what is our S2? E minus R2. Yes, but we now call this equation 5, formula 5, we are to remind ourselves about. Now, what is the value of E? We have not talked about that. So what we now do to get the value of E is that look at this ray, refracted ray. Look at it. Look at R2 and look at E. You now say, recall that refractive index is equal to sine of emergent all over sine of refraction, that is R2. Now, you now say that therefore refractive index will be equal to, therefore sine E will be equal to, therefore E will be equal to sine inverse bracket refractive index times sine R2. Sine inverse, because when you cross multiply this will times it to give you n sine R2, refractive index sine R2. It now equal to sine E. Therefore, E will be equal to sine inverse of the product. Then, what is our R2? You say equals to sine inverse. That means E is equal to sine inverse of n sine, what is our R2? N sine A minus sine inverse of sine I all over refractive index. Okay, so you now have this to be the formula. That is sine inverse bracket refractive index sine. Then replace your R2 with what you have in equation 4. That is A minus sine inverse bracket sine I over. That means get your sine I over refractive index, get the sine inverse of it, answer you get, minus it from A, answer you get the sine of it, multiply it by refractive index. All this thing will be done with calculator and you get it fast as possible. You call this equation 6. Then we go to another formula we need to recall to ourselves. Once I get all this formula, I'll just press it in calculator. Within 10 minutes, I am done with everything. Just use my calculator and get my answers. Okay? So while going to equation 7, what you say is that since our d is equal to this, it's also important to note that d is equal to I plus E minus A. D equals to I plus A minus A. This is equation 7. This is equation 7. That means when you say I minus R1 plus E minus R2, what it will give you will be equal to I plus E minus A. And we have noted how to get our E. So we go to equation 8. For you to talk about equation 8, you have to consider a special case where R1 is equal to R2. You say when R1 equals to R2, call both of them R. Call this one R, call this one R. Don't put 1 or 2 to any of them because they said it is equal. And in that case, E, the emergent angle, will be equal to incident angle. When the refracted angle are equal, it means that emergent angle will be equal to incident angle. Now, another thing you have to also note is that when such case come up, you say that the D will be equal to minimum angle of deviation. The angle of deviation will now be called minimum angle of deviation when this case comes up. Then what you now do here is you now say, at this A equal to R1 plus R2, you will not call R1 again R2, you call it RR. A equals to R plus R, that is 2R. You will be having A equals to 2R. Therefore, R will be equal to A over 2. Note this as equation 8. Please remember that since we have D equal to I plus E minus A, you can have that if they ask you to get I, you say I equals to D plus A minus E. That is D plus A minus E. With minus A going to that side will be plus A. Then D plus A minus E. You say equal to I. Then you call this 7II. Let's say equation 7II. Then we also have it that E is equals to D plus A minus I. Emergent angle, it's just all about making subject of formula equal to D plus A minus I. This is 7III or 7B. Let's say 7B and 7C. Equation 7C. Yes, this is equation 7A. Please note it. And this is equation 8. Then, noting that D equal to I plus E minus A, and we say that at this case E is equal to I, it still means that D is equal to I. Remove the E and replace it with I because E is equal to I, then minus A. So you'll be having I plus I, 2I. You'll be having D equals to 2I minus A. Therefore, I will be equal to, I repeat, so that you will not make mistake. When this case exists, that E is equal to I, it means that wherever you see E, replace it with I. And when you do that, the D there will be called the minimum deviation. So you call it minimum deviation equals to I plus I minus A. I've replaced the E I have with I. Then we now say that minimum deviation is equal to I plus I 2I minus A. Therefore, making I subject of formula, I will be equals to Gm plus A all over 2. We know what our A is, 60 degrees, and so on and so forth. So we call this one equation 9. Equation 9. Then we now say also that since we have gotten this to be equation 9, remember that refractive index is equal to sine incident angle over sine of refraction angle. And our R at this case is A over 2. And our I at this special case is dm plus A over 2. What you now say is that this will be equal to sine, what is my I? Dm plus A all over 2. Then all over sine, what is my R? A over 2. So when we finish performing this experiment, if we are asked to get our refractive index, then we must have gotten our dm from our graph, know our A, we package it in this formula and get our refractive index. Remember, this will be our formula 10. So note it. So at this point, we've been able to see all the important formulas we are to use, because we don't want to touch the apparatus, maybe because we have eye problem, or maybe we want to perform this experiment in the midnight where there is total darkness and we want to get the excellent answer to that. Using these formulas will help you to get your answer very accurate as possible. Then after getting it, you will use the answers you got and just use your protractor, your ruler, and a sharpened pencil to sketch your triangular prism. Just be locating the values you got, locate it with your protractor. That will be within minutes you are done with that one, so that then we see it as if you perform the experiment and see everything excellently done. As I said in the beginning of the video, I so much appreciate you all for being part of my channel, for sharing my videos to your friends who are finding one or two courses difficult in science courses, and also for your comments and your encouragement. I so much appreciate. Please feel free to share this video to anyone you feel it can help as well. I will appreciate. And as you watch it, please don't forget to click like and click subscribe button. Click it to be part of my channel to enjoy many videos will be posted. This is the part 1 of this major experiment on triangular prism. In the next video, we will see how to use these formulas and get our table within minutes. Thanks for watching the video.